Hey, Algebra 2. We are ready for the last section here in solving quadratic equations. Okay, and we're going to get to something a little strange, something called an imaginary number. Doesn't really mean it's just fake, okay? It's an actual number that was developed 400 years ago, okay? So basically, let's say we're going along trying to solve this problem, okay? Just going along here. And so I would subtract 12 from both sides. We get 3x squared equals negative 12. We divide by 3. X squared equals negative 4. We go to take the square root of both sides and we say, whoa, whoa, whoa. Can't take the square root, no solution, or sometimes we write no real answer. Okay, and that's true. There's no real answer, but there is an imaginary answer. Okay, a number that René Descartes, a French mathematician, came up with so that we wouldn't have to stop anymore at solving these problems. Okay, we could keep going. And that might seem silly, but there are areas that use imaginary numbers where you work with the imaginary number and that brings you back to the real number system. Okay, electricity, they use imaginary number in electricity. They also use it in physics. Okay, there are other places where we do use the imaginary number. Okay, so here's René Descartes. This was his problem. He said, let's solve x squared equals negative 1. We'll solve that by taking the square root of both sides. And we are going to introduce a new number, a little lowercase I. We're going to call I the square root of negative 1. And notice what happens if I take the square root of negative 1 and square it. That brings me back to negative 1, which is a real number. So I squared is negative 1. The square root of negative 1 is I. This is our new number. Okay, so now I can continue with this problem and say x equals plus or minus, I'm thinking of this as the square root of negative 1 times 4. That's still negative 4. We just said that the square root of negative 1 is this imaginary number called I. I know that the square root of 4 is 2. So this is going to be plus or minus 2i. Those are my two answers, okay? If it was just the square root of 4, the answer would be plus or minus 2. Since it's the square root of negative 4, the answer is plus or minus 2i. There's a little quote by René Descartes, very famous mathematician. Each problem that I solved became a rule which served afterwards to solve other problems. So developing this imaginary number, he was able to go on and solve other problems in physics, other problems that have to do with electricity, okay, electrical circuits, okay, we use the imaginary number to solve problems with that, okay? We've been graphing our parabolas, right? Graphing our quadratic equations. Like I said, we were trying to solve 3x squared plus 12 equals 0. And I've been telling you, hey, graph y equals this. See where it crosses the x-axis, and those are your answers. This never crosses the x-axis because there are no real answers. Okay, that's another way to see this. Okay, however, we're no longer just going to say, hey, there's no real answers. We're going to say there are imaginary answers, okay? And the answers are, like I said, plus or minus 2i, all right? Now, when I have a number like that, something that we just have some number I, that's called a pure imaginary number. I think I have that written in your notes. If I have something like a plus bi, where, again, a and b are real numbers, maybe something like 3 plus 7i, we call that a complex number. It's complex because it has a real part and an imaginary part, okay? Now, technically, we could say that all numbers are complex numbers, and we do extend the real number system to be the bigger set is the complex numbers, because I can write 3 as 3 plus 0i. And now I've written it as a complex number, even though it's a real number 3. Okay? I can call pure imaginary numbers. If I have 6i, I could say 0 plus 6i. Now it's a complex number. Okay, so by putting 0 either in front of the I or 0 as the real part, every number is actually a complex number. Okay? Now, we're going to learn how to simplify these. All right? And when you simplify, you always make sure you take the I out first. So in other words, here I have 4x squared equals negative 100, right? Sorry, I'm subtracting 100 from both sides. I divide by 4. I take the square root. And this is where we're going to take I out first before we simplify. Okay? In other words, I'm thinking of this as plus or minus the square root of negative 1 times the square root of 25. That's still the square root of negative 25. The square root of negative 1 is I. So usually what happens is we go right to this step. When I see square root of a negative, I take the negative out, or I take the I out. When I take the negative out of the square root, it becomes I. Now I have I square roots of 25. I should have put plus or minus there. I know that, let me put it there. Sorry about that. Equals plus or minus I square roots of 25, which is plus or minus. I can take the square root of 25, right? It's 5. So this answer is plus or minus 5i. All right. So let's simplify some things that maybe I can't take the perfect square of. Square root of negative 18. What they're saying, okay, as soon as I see negative, I'm going to pull that out. Now listen, guys, the square root's already here. I don't have to put a plus or minus, okay? The square root is already there. I wasn't, in this problem, there was no square root. I put the square root in. I took the square root of both sides. I have to put the plus or minus. Here, they just want the positive square root. So I'm going to bring the negative out and make this I square roots of 18. Bring the negative out, I square roots of 12. Okay, always bring the negative out and then simplify. 18 is 9 times 2, isn't it? What's the square root of 9? Yep. So simplified, this would be 3i square roots of 2. 12 is 4 times 3. I can take the square root of 4. The square root of 4 is 2. So simplified, this would be 2i square roots of 3. Okay, so we're simplifying these just like we always have, just this extra step with the I. Negative 2i times 5i, I'm just going to multiply 2 times 5, negative 2 times 5 is negative 10. I times I is I squared, and then I remember that I squared is negative 1. So I have negative 10 times negative 1, which is positive 10. I took 2 imaginary numbers, multiplied them together, and got a real number. That's why imaginary numbers are important. We can work in the imaginary world for a little bit and come back to the real world. Doesn't even sound like I'm talking math anymore, does it? Let's take the I out first. This is I squared to 8 times I squared to 48. You always take I out first. Okay? And then let's just take 48 times 8. I'm going to use my calculator. That's 384. So I have I squared times the square root of 384. I don't think I can take the square root of 384. Okay, that's not a perfect square. I tried on my calculator, it gives me yuck. So I'm going to take 384 and divide it by some perfect squares. Does 384 divide by 4? Yes, 16. You know, you find the biggest perfect square that you can. You just play with your calculator. I have I squared. 384 is 64 times 6. I can take the square root of 64. It's 8. So I have 8I squared 6. And this whole time, you've probably been thinking, wait a minute, I squared, I can write that as -1. This is 8 times -1 times the square root of 6, which is -8 square root of 6. Again, two imaginary numbers, multiplied them together, and got a real number. Adding and subtracting isn't too bad. You just add the real parts and add the imaginary parts. It's very, very similar to just combining like terms in algebra. 7 and 4 is 11. -3i plus 1i would be -2i. Just like -3x plus 1x is -2x. Right? You just kind of carry the I along when you're adding and subtracting. All right. I thought I had another thing. Wait a second. Sorry. I wanted you to multiply too. There it is. Gee, I knew I had it somewhere. Sorry. Subtracting, you're going to distribute the negative through. -3 minus 6i. And now we'll add and subtract the real parts. 9 minus 3 is 6. 5i minus 6i, -i. Done. We're going to FOIL like we always have. 3 times 4 is 12. 3 times -5i is -15i. Let's move to the 2i times 4 is positive 8i. And this is minus 10i squared. Remember, I squared is -1. I'm going to combine my i's here. -15i plus 8i is -7i. And here I have -10 times -1. Well, -10 times -1 is positive 10. I can add the 12 and 10 and get 22. So the answer is 22 minus 7i. Okay, I've FOILed. I combined my middle terms like I always do. -15i, like when they're x's, right? -15i plus 8i is -7i. My I squareds, I changed to -1 and then multiplied -1 times -10 to get the positive 10, combine that with 12 to get 22. Now I can show you the homework, which you saw in Schoology. Guys, break out that Algebra 2 book, all right? I sent it home way back in the beginning of the school year. We haven't used it much because I've been trying to use online things, but I want you to do these problems out of the book. Okay, page 279 to 280, 3 to 11 all. I think they're multiple choice type things. 12 to 26, just the evens. And then 51 to 54 all. I think there's some sort of matching there. Then go to page 296 and try these problems. Okay, 22, 26, 27. I tried to give you a variety. There's like more of the adding and subtracting. Okay, all righty. We will see you in class. Bye-bye.